In this demonstration, we'll look at things you can do to optimize an enterprise wireless network. The first task is to manage access point power levels. Access point power levels can help spread or weaken the wireless coverage. More power provided to an access point can increase both coverage and speed. However, you don't want access points to be overpowered, which would cause too much overlapping coverage. Also, distortion and interference can be caused by overpowered access points. Originally, some wireless controllers didn't have the capability to auto-determine transmit power called TX power. But the Cisco Wireless LAN Controller, or WLC, we use in this demo can auto-detect TX power. Let's go to wireless and then go to 802.11a. You can see a drop-down for RRM. This stands for Radio Resource Management. This Cisco built-in tool automatically detects and configures access points. It also gives statistics. 802.11a is the 5 GHz, while 802.11b is the 2.4 GHz. Both radio frequencies have an RRM configuration. Let's check it out. If you have multiple WLCs, one must be the leader. The RF grouping determines the WLC that is the leader. The TPC algorithm controls the TX power. There is an option up here to select coverage or interface. If you're more concerned about coverage, you leave coverage optimal mode selected. Although you can set TX power to fixed, it's usually best to set it as automatic. The Dynamic Channel Assignment, or DCA, feature can automatically assess how much TX power is needed. If two access points are near each other, use the same channel for both. It's possible that the access points could interfere with each other. This setting used to be manually set. The coverage setting gives you information to see if more access points are needed or if they need to be relocated. Let's look at settings directly on an access point. If we go to wireless and then to all APs, you can see the two connected access points. If you click one, it provides more settings related to the access point. We could rename this AP to lobby, for example, to indicate that this access point is in the lobby. In the advanced area, we have more information and can change the AP group name and other settings. The Power over Ethernet, or PoE, settings say the AP is running at 15.4 watts. However, the access point is capable of running PoE+, which can be up to 30 watts per port. Because the switch the access point is plugged into doesn't have PoE+, the access point defaults to 15.4 watts. Click Apply to save the settings. The last topic we'll look at in this demonstration is load balancing. Load balancing is an important network technology. It balances the load between two or more access points to provide optimum performance. It redistributes the load between access points to eliminate overloaded and underloaded conditions. Go to Wireless tab, Advanced, Load Balancing. There is an option to configure. Cisco calls this aggressive load balancing if you search for information on this. The client window size is used with the Cisco algorithm to determine a busy access point. This value can be adjusted from 1 to 20. The default is 5. The maximum denial count sets the max number of times client associations can be rejected by a certain access point. Since we currently don't have a heavy load on the access points, we'll leave the default. These are global settings, but if you see this note below, you must enable it per WLAN. Otherwise, settings will not be in effect. Let's go to the WLANs tab and then to the Test Out Network. In the Advanced tab, there is an option for client load balance. Let's check that and click Apply. There are some warnings, such as the first one, that says it could impact applications like voice. After we click OK, another warning says wireless connectivity could be affected as the radio resets. Click OK again. Remember to click Save Configuration in the top right-hand corner. This is always required. Otherwise, the changes will not be there if the WLC is rebooted. That's it for this demonstration. In this demo, we talked about some things you can do to optimize an enterprise wireless network. We first showed you how to manage access point power levels. Then we covered a wireless network setting for RRM. We ended this demonstration by showing you how to load balance between access points.